Hi everyone, we're continuing with the critical reasoning video series. Video series. In this video, we're going to cover the rules of logic. So it's rules of logic for critical reasoning or what have you, which means these are actually real rules of logic. So you can use them in real life or for any other purpose. And this is good because basically whatever you learn here is something that you're going to apply in the rest of your life, for the rest of your life, unlike some other principles from, let's say, the reading comprehension section. Although you can also apply those. Okay, these are not all the rules of logic that exist in the world of logic, and some of these are not even consistent with other systems of logic. But remember, these are the rules of logic that work for the GMAT and the GRE exams, just in case there's any philosophy student watching this. Okay, so I'm not claiming that these are only the rules of logic that are like to follow in life. Okay, so principles to apply the rules of logic. The first principle is that natural language is deceptive. Okay, like even the word deceptive is kind of deceptive. Like, what do I mean by deceptive? So I mean like they may lead you to think or believe something that is not true. And basically when you're working with arguments the way we are in the critical reasoning section, if we just work with words, like with natural language, with the full sentences, we may not get a clear idea of what we're doing. Okay, so we're going to exemplify this with when we reach the problems of logic. Okay, another principle is remember that we're dealing with arguments. And as you may or may not remember, an argument consists of premises and a conclusion. So you have a set of premises, which are facts, and that set of premises pretty much leads to a conclusion. And that has to follow a logical path. Okay, the third thing to remember is that we are going to deal with operations and formulas. This is not always the case in critical reasoning, okay? Like this is the case for this specific video, but there are extra things in the critical reasoning section that are not covered by this video, and we're going to cover in their own videos. Okay. So things that we want to do for the critical reasoning, applying the rules of logic, we want to translate from the natural language to logical language. This is why we want to start learning how to use some symbols and some variables in order to know what is the main idea or the main logical idea behind a statement. The second thing that we want to do, we're going to apply the rules as they are. So we're trying not to modify the rules, especially not to modify it into what we would like them to be. They just are what they are. Okay, and another thing we have to do is we have to think outside the box. If you have the time, this will be a very useful skill for you. So you have to get outside of your mindset, because you're going to notice that some of the logical mistakes are actually mistakes that we made in our day-to-day life, in our day-to-day reasoning. Okay, so you're going to start practicing actually applying these rules of logic to your own life. Okay, things you don't want to do, do not autocorrect. Remember, whatever they write in the text, it is what they meant, okay? So don't think that, they actually mean something different. They just made a mistake. They are not making mistakes. I mean, they may, but they are not. Do not rely on hunches. Do not rely on what you think sounds true or what you want to be true. And do not adapt the rules too much. I mean, yes, you have to adapt the rules to the specific case. And for example, when you practice this in your everyday life, you will going to notice that, yes, we're adapting them a little bit more. There's room for adaptation, but not too much. Don't kind of go outside the actual rule. Okay, so we're going to start checking the basic rules applied in critical reasoning. Again, these are not all the logical rules, and I'm separating this into rules to follow and things to avoid, right? So the first 5 will be things that we have to follow, and the second 5 will be things we have to avoid. They are all logical rules. You can Google them, you can Wikipedia them, you can remember this from school, you can ask your teacher about this, and these are all basic general rules that exist in real life. Okay. So we're going to go with the first ones that are the ones that we want to follow. So the first one is the modus ponens. You may remember this from school. You may remember this from college. I am using the Latin name of this because it's like the easiest thing to find when you Google it. You don't have to use the name. Actually, you don't even have to remember the names of these rules. And if you don't have the time, don't even think about remembering the name. Okay, like if you do have the time, like let's say you have 6 months to study for the GMAT or for the GRE, go ahead and learn everything, because it's definitely going to add up to your education or actually to your preparation. But if you don't have the time, just drop the name. Okay. Okay. So what does modus ponens look like? I'm first going to show you the logic and structure, and then I'm going to give you examples. So P, therefore Q, you have P. The conclusion, you have Q. How do we say this in natural language, Christian language? We say it like this. So I have my P, therefore Q. If it rains, my floor gets wet. So I have, this is my first premise, right? I have an event, it rains, and then I have something that is going to be a result of that. So if it rains, my floor gets wet. Then I have my second premise. It rains. So it actually rains. Let's say it's actually raining right now. And then this is going to symbolize my conclusion. Therefore, and this is the conclusion, my floor gets wet. This is what we mean by modus ponens, and this is a completely correct logical reasoning and logical way to get the answer, right? So if the first causes the second one and you have that the cause occurs, then the consequence has to occur, okay? So we're going to go to the next one. The next one is the modus tollens. So I have P causes Q, but Q doesn't happen, then it's not P. So P didn't happen, right? And the way to exemplify this is, again, we're going to use the same example. If it rains, my floor gets wet. My floor is not wet, so I go outside and I see that my floor is not wet. Therefore, my conclusion is that it didn't rain. Again, this is a perfectly correct way of reasoning, right? So I have a cause and a consequence. The consequence didn't occur, so I can safely conclude that the reason or the cause didn't occur. Okay. We go to the third one, transitivity, which is also a property in math. So I have P causes Q, Q causes R. So if P occurs, R occurs. So we go to see the example in natural language. So say, if it rains, my floor gets wet. If my floor gets wet, it reflects the light. Therefore, and this is the conclusion, if it rains, my floor reflects light. So again, if we have the cause, we have a consequence. Now, this consequence is going to be the cause for a new consequence. So by transitivity, if I have the first cause, I will have the last consequence, which is, again, a completely logically correct conclusion. We're going to go to the fourth one, the double negation. Again, this is something you may be familiar with, especially in English. Again, in your native language, there may be a tense of double negative being correct, but in this case, we're going to use the logical double negative, okay? So if I have an event, a fact, and I negate the fact, and then I negate the negation of the fact, then the conclusion is going to be the fact itself. So again, in natural language, I have, it is not true that it didn't rain, right? So I have the rain, I have the negation of the rain, it didn't rain, and I have the negation of the rain. So this is like a double negative thing. So basically the conclusion is that it rained. It's basically the same thing we do when we multiply negatives times negatives in math. Okay. The fifth rule is the logical opposite, which means, again, this may seem pretty obvious, but the negation of the fact is equal to the negation of the fact. Again, this is so this is important because when we translate to negative language, to natural language, we're going to see how this language is deceptive, right? So the opposite of something is just not that something, okay? And this is important because language contains meaning that is not exactly the same as the logical meaning of whatever we're working with. So, for example, the negative of all, some people will think is none, right? And actually, I should have asked you this, but the negative of all is not none. The negative of all is just not all, okay? It's a mistake to think that the opposite of all is none. If I say, not all humans wear glasses, okay, then you cannot conclude that no human wear glasses. You just know that some human, right? Some humans wear glasses. The same way, the opposite of none is just at least one. So basically you're saying not none, okay? And I'm stressing this a lot because this is very important. It's a very common mistake for people to think in terms of antonyms, right? If you think in terms of antonyms, you think that the antonym of all is none, right? So you think, okay, of course, then the opposite of all is none, but it's not the case. So again, the opposite of nothing is not everything. The opposite of nothing is something. Again, you just want to say not nothing, which is something. And this is very important. We're working with logical opposites. The opposite of everything is just not everything. The opposite of increase is just not increase. The opposite of decrease is just not decrease. I'm going to stop here for a moment because remember, you always have two options, okay? You either increase, you decrease, or you pretty much stay the same. And this is important because sometimes the question will be something like sales have not increased, right? So if sales have not increased, you don't know whether sales have decreased or not. Maybe sales just stay the same. And this is a common mistake that happens in critical reasoning and in life. Okay, then we go to the, we already finished the 5. Okay, so we're going to go to the rules to avoid, or to the logical rules to avoid. So these are all fallacies, these are all mistakes of logic. Okay, so the first one, number 6, denying the antecedent. So we have P causes Q. P didn't occur, so you may think that Q didn't occur, right? This is actually incorrect. Why? Because maybe there are other causes for Q, which you have to take into account, right? So this looks like this. If it rains, my floor gets wet. And you say, it didn't rain. Okay, so therefore my floor didn't get wet, which is not correct. It may be true in real life, right? It may be true that the only way for your specific floor to get wet is that it rains, but it's not really true. It's not logically true. Why not? Because there are other possible causes. Maybe someone can spill water. Maybe I can just open a hose and maybe there's a tube that is broken or something. That there's always another possible cause. And this is why I was telling you that you had to keep your mind open. Like, you have to always look for alternative causes. Okay, always. So again, this is an incorrect way of reasoning. This is a thing you want to avoid, and this is a type of mistake you're going to find in the mistake type of question. Okay, the another mistake, this should be the 7, is affirming the consequence. This is number 7. Okay, affirming the consequence. So I have, if P causes Q and Q is correct, then P is correct, right? That is completely incorrect because, again, we don't know which caused it, right? So again, if it rains, my floor gets wet, right? My floor gets wet, therefore it rained. This is false because we don't know, then again, whether there was another possible cause. Again, in real life, maybe this is true, but it's not logically correct. Okay, it's not logically correct that this is necessarily the conclusion that stems from this argument. Okay, maybe someone spilled water, maybe I broke a pie, maybe we had many different options. Maybe I just pee all over my floor. Who knows? Okay, then we go to the 8th mistake, is assuming causation. So if you have P and we have Q, let's say those two things occur, or maybe occur one after the other, we may assume that one is causing the other. This is completely incorrect. Again, the way we exemplify this with natural language is like this. It rains, my floor gets wet. Therefore, if it rains, my floor gets wet. In this case, I know I'm contradicting a previous example, but remember, these are all independent examples. It just happened to be talking about the same thing. So I don't know whether my floor got wet because it rained. Maybe it rained, yes, but maybe my floor has a roof. Maybe this is not the floor of my patio. I never said that this was the floor of my patio, right? I mean, maybe we're just assuming that it is, but it's not. So maybe it just happened to rain and someone spilled water at the same time, right? So remember, just because two things happen at the same time or one thing happened after the other one, it doesn't mean that they are related. Again, something you can take for life too. Okay, the 9th mistake is assuming an only cause. This is kind of going around the same thing. So you're saying, like, if P causes Q, then it's not the case that R causes Q. Again, this is incorrect. We have to open the possibility to other causes. So you say, if it rains, my floor gets wet. Therefore, it's not true that if I pour water, my floor gets wet. Now you can see how illogical this is. Of course, there are other possible causes. There are always possible causes in real life too. So again, try to use this in your day-to-day life, so you can kind of practice in an active way finding mistakes in your reasoning. We all have mistakes in reasoning. Okay, the 10th mistake is hasty generalization, which again, it formally looks something like D. If P, therefore Q, then therefore P, therefore R. This is obviously incorrect when I put it like this, right? Of course, you cannot conclude R. There's no relationship between Q and R. But in natural language, this looks like this. And this is why you want to work with symbols and not natural language. You say, if it rains, my floor gets wet. Therefore, if it rains, your floor gets wet. Or worse, if it rains, every floor gets wet. So you're saying, just because this happened to one individual case, to my floor, it will probably happen to all the floors. So you can think of this as a hasty generalization, and we do this kind of all the time. For example, right now I just did one. Like, since I made that mistake, I'm assuming that all humans made this mistake, which may not be true. They may be humans who never ever make this mistake. So if you notice, we are making these types of mistakes all the time. So I want you to practice being aware of this, both in your own reasoning and in the reasoning of the people around you. Again, this is why it's important to work with symbols instead of just working with natural language, because with natural language, this may not be that obvious, but once you translate it and like this is a completely different letter, then you can see that, of course, there's no relationship between Q and R. So natural language is deceptive, because if I say, I made mistakes, you made mistakes, like all my family made mistakes, so therefore, yes, of course, all humans make mistakes, but there is no relationship between those two. Okay, finally, remember that these are not all the rules. There are some other rules. These are just the basic rules. Remember that it's good to practice applying them in your everyday life. Like, this is a skill that you're developing, so develop it with real examples. Again, you are going to find these types of mistakes or these types of rules in your everyday life. And remember to have a cheat sheet for formulas, so don't have to memorize them at the beginning. You can just write them down in a piece of paper, and every time you solve a critical reasoning, you can just go ahead and check this, and until you finally memorize all of these rules. Okay, so that will be it for the rules of logic. We're going to continue with the critical reasoning preparation series. Remember, please, to like, share, subscribe, and leave any questions that you may have in the comments. I will answer them, and see each other in the next video. Bye.